Okay, so this is the ninth problem in the grind 75. This one is flood fill. We're given 20 minutes, so we're going to start now. So let's see. Yes. An image is represented by an m by n integer grid image, where image row index column j, I think, yeah, row index column j, or row I column j, represents the pixel value of the image. Okay. You are also given three integers SR, SC, and color. You should perform a flood fill on the image starting from the pixel image SR, SC. Okay. To perform a flood fill, consider the starting pixel plus any pixel connected four directionally to the starting pixel of the same color as the starting pixel. Okay, I'm just going to read that again. So to perform a flood fill, consider the starting pixel plus any pixels connected four directionally to the starting pixel of the same color as the starting pixel, plus any pixel connected four directionally to those pixels, also with the same color, and so on. Replace the color of all of the aforementioned pixels with color. Return the modified image after performing the flood fill. Okay. So I didn't actually totally understand that. Maybe the example will clear up a little bit. So our source row, I'm assuming that's what S stands for, source. Our source column is, they're both 1. So row 1, which is here, and column 1. Okay. And we want to make the color 2. So plus any pixels connected four directionally to the starting pixel of the same color as the starting pixel. Okay, so what does four directionally mean exactly? Because, oh, wait, so this is my guess right now. I think it means just up, down, left, and right. No diagonals. Um, because our source will change anything that is four directional, I guess four directionally adjacent, and it has the same number. So it will change these, the left one and the top one. Plus, if those get changed, then everything that's four directionally adjacent to those should also change. And that's why the zeros don't change, and neither does this diagonal one. But let's actually look at the explanation really quick. So from the center of the image with 1, 1, all pixels connected by a path of the same color as the starting pixel are colored with the new color. All pixels connected by a path. Okay. Note the bottom corner is not color 2 because it's not four directionally connected. Yeah. So four directional, which I will just write in the notes really quick. Sorry. That's so four directional is up, down, left, right. Just so we don't forget about that. Okay. And let's just look at our constraints really quick. M is equal to image.length. Does that make sense? Yeah, row, or wait, M is, yeah, row by column. Yeah, okay. So the N is equal to image I dot length. So there doesn't have to be the same number of rows as columns. It's just that each row length must be the same length. So we could have 3 total rows, but the row length could be 2. So we would have 2 columns. Hopefully that makes sense. The number of rows will be 1 at the minimum, and the number of columns, one is, will be at most 50. Okay. So the row is 0 to m. Yeah, okay. Okay, this makes sense. So let's see. I guess this is technically a matrix problem, I think. So how do we want to do this? I'm going to look at this example. So let's actually think about which indices these are. So this is 1, 1. Let me actually go over to, gonna go to the drawing board and just illustrate this. I think we're taking a kind of a large amount of time, but I want to make sure I am doing this right. So we had a grid that was, I'm not going to color, I'm just going to focus on the numbers. It was 1, 1, 1, 1, 1, 0, 1, 0, 1. And this index right here was 1, 1. This index right here is row 2, column 1. This is row 1, column 2, row 1. This is row 1, column 2, sorry. This is row 2, column 2. And this is row 0, row 1. Hold on. I feel like I messed up somewhere. 0, 1. Column 0. Row 1, column 2. Okay. This is row 0, 1, column 0, 1, 2. Yeah, so that one up there is incorrect. This is row 0, column 1. Okay. So basically every alteration to our original source row and source column is going to be a single index difference for either the row or either the row or the column. So we can do -1 for the row, or we can do +1 for the row, or we can do -1 for the column and +1 for the column. But we'll never alter both values by 1 because that would give us a diagonal if we were to add both. So yeah, we can just think about how we would do that. And then once we check the appropriate values, maybe we would probably want to do this recursively. And yeah, so it's not exactly a loop. It's like we're checking 4 separate conditions, almost, it seems like to me. I'm going to look at the example again really quick. Let's switch over. So, say we start off at our source of 1, 1. We would check, okay, well, we also don't want to go out of bounds. So how do we ensure we don't go out of bounds too? Because this one is put nicely in the center, we have to remember, I'm actually going to put these up here just so they're within view. We don't want to go past our row boundary. which would be M, or our column. Well, so let's see. Image.length is row. That's the number of rows, which is technically column length. And that would make this row length. So say n image one index dot length. So there was 2 of them. Wait, did I mess that up? Say we take image at index 1, we get the length, so that would be this. It would be of length 3. Yeah, no, that means that there's 3 columns. And if there's 3 of these, we can imagine them as being stacked on one another. So that would be row length, actually. Okay. So let's see. Let's take a look at our illustration again. And let me switch over. Okay. Okay, but how do we want to do this in a step-by-step manner? So, I mean, what I'm seeing right now is to do 4 if checks. I'm sure there's a more elegant way to do it. Let me switch over to LeetCode so we can see the notes. 4 if checks. So first check if within bound, then check if pixel matches. Pixel value matches. So if it does, and what is it exactly do we do? We switch it to what color is. And what would be our base case? If there's no matches. Well, yeah, I guess base case. So if no matches, just return. And basically we're just going to return an image because we're going to alter the actual object destructively. Return the modified image after performing the flood fill. Okay, so I am just going to start writing and see if anything comes up. So right now I'm going to assume that we don't have to account for any strange cases. I will look into that a bit later. I just want to get the main logic down right now. So let's see. Okay. Color. And it has to be the original value too, though. Because like, if there was a 2 here for this 0 right here, and then we took these original indices and said anything that is 4 directionally adjacent, we want to make that our target of our color of 2, and then recurse onto this value, same thing, anything with the value at that point, which we actually don't want to do. I mean, I could make a separate function Okay, I'm going to make a helper function. I'm just going to call it public int. I guess we don't need to return anything. Public void flood fill. This one's going to be called logic. We're going to take int. It's going to be image our sc. The key differences are going to have int match, which is the value we want to detect, and then int color, which is the value we want to switch into. We're going to start off. We don't actually need to nest these functions. Go and put this down here. I'm going to start off by calling flood fill logic with image sr sc, image at sr and sc, and then we're going to pass in color. That's going to allow us to recurse properly. So I'm just going to start off by checking. So if yeah, okay. So let's say we want to check to make sure it's within bounds at all times. So I mean, there might be some other easier way, but I'm just going to start off by looking at our first example. So let's say the row value -1. So maybe if SR -1 is greater than 0, meaning it's still within the bounds of our image, and we're going to say image at SR -1 and SC is equal to match, then what we're going to do is set image at that appropriate place. We're going to set that equal to match, and then we're going to recurse on it. Flood fill logic, and we are going to pass in int going to pass in image again. We're going to pass in, what is it, SR -1. Going to pass in same column, same match, and sorry, we don't want to make it equal to match, we want to make it equal to color. We're also going to pass in the same color. Okay, yes, and we're going to repeat this for each possible alteration, and I'm just going to put this together really quick. We have about 20 seconds left, but I'm just going to finish it up and see if it runs. So I'm actually going to stop the countdown and just fill out the rest of the function like this. And we're going to say maybe if s plus 1 is less than, so this we actually want to make greater than or equal to 0. This we want to say is less than image.length Yes. And image at SR plus 1 and SC is equal to match. Then we are going to want to image at SR plus 1 SC, set that equal to color, plus fill. We are going to want to pass an image, pass in that alteration we made, pass in the original column, keep the match, and keep the color that we want to change the match to. And semicolons. Another else if condition. So actually, we don't want to else if, we want a separate if statement altogether actually, because we want to make all of these recursive calls. And we're going to say if source is the same, so actually if the column -1 is greater than or equal to 0, and you know the drill, image at the same row but that altered column is equal to match, then we're going to want to change image appropriately, the proper source, and the altered column, set that equal to color. Then we're going to do flood fill logic. I'm sure there must be a much more elegant way of doing this, because I'm literally repeating the same statement 4 times. But I'm just going to brute force it, and then we're going to patch it up when we go over the solution. So image source, or row is what I mean to say. Column -1, original color. Okay. Then if +1 is less than image I dot length, and there is a match, image at SR SC +1. Then, as we've done in the past, we want to change image to row and to column +1. We also want to call the function again. Okay, image, appropriate row, appropriately changed column, the match value, and the color value. Okay, I believe there's some sort of base case we're not accounting for. I'm gonna return image again. If we go through all of these if checks and none of them pass, then we've probably run into a base case, but you know that's not a good position to be in, not knowing whether or not we actually have run into a base case. But I'm just going to run this and see if it passes some of the cases. Let's see. Yeah, so we should probably, or let's do, because originally we were doing these if-else statements, but we want to make them separate if statements. So let's try this again. 17. Let's see. So missing Line 16, expected to close parenthesis. Where exactly am I missing that? I have a comma here, which I definitely shouldn't. Maybe that's what it meant? Okay, another. Sorry, yeah, forgot to set that equal to color. Okay, cannot find symbol. Flood fill logic. Well, because I did not spell it right. Okay, that's spelled right. Okay, several little cases, can't find symbol. Finish dot length. Image at I. Well, I can safely say 0. Bad operand. Go to match. Okay, accepted, but let's actually submit and see if that works. I'm assuming there's a base case we haven't accounted for. Yeah, Stack Overflow. At line 10. Okay, I'm going to stop the video here. I'm going to think about the problem a bit more myself, and then, as I said earlier, we're going to clean up the thought process once we go over the solution.